All right, you guys. So today we are going over that worksheet you got a while ago. You remember they had to draw the pictures on that equilibrium worksheet, okay? So here are the first three. Technically, it's number 2. And we are asked to solve for the tensions in each of these, okay? So we're told that in case 1, in case 2, that the mass is 5 kilograms, which means we can find the force of gravity by doing 5 kilograms times negative 9.8 meters per second squared. And that's going to be the force of gravity for both of them, since it says that both of them are the 5 kilograms, okay? So when we do that, we get that the force of gravity is equal to negative 49 newtons. All right? Now, for this first one, solving for tension is really straightforward. What we're going to want to do is sum the forces in the y direction. And when we do that, we're going to get that the force of gravity plus tension is equal to 0 newtons, since this is equilibrium. And in order to get tension alone, we have to subtract the force of gravity from both sides. So we get that tension is equal to the negative force of gravity, which means that tension is equal to negative 49 newtons, which means that the tension here in case 1 is 49 newtons. All right? Now for case 2, we're going to follow very similar steps. We're going to once again sum all of our forces in the y direction, but this time we have 2 tensions. So we're going to have T plus the force of gravity equals 0 newtons. What we can do here is we can take these 2 T's and combine like terms to have 2T plus the force of gravity is equal to 0 newtons. Now where we go from here is that we're solving for T. So once again, we're going to want to subtract the force of gravity from both sides. So we're going to get 2T equals negative force of gravity. And the last thing we do to get T alone is we'll divide both sides by 2. So we'll get that tension is equal to the negative force of gravity divided by 2, which means negative 49 newtons divided by 2. All right? Now when we type that into our calculators, that means that our tension is equal to 24.5 newtons. So each of these tensions is 24.5 newtons. All right? So these two are pretty straightforward, but now we need to move on to case 3. And we have 2 free body diagrams here. So what I'm going to suggest is that we start with this one, okay? Now we're going to start with this bottom one, and we're told that the mass of this object is equal to 4 kilograms, all right? So this is going to be 4 kilograms times negative 9.8 meters per second squared. And when we type that out, we get that it's equal to negative 39.2 newtons, all right? So we're going to go ahead and solve for T2 by summing just these y forces. And when we sum just these y forces, we get that T2 plus the force of gravity on object 2 is equal to 0 newtons. So once again, we get the really straightforward answer that our tension is equal to that negative force of gravity, which means that it's going to be equal to 39.2 newtons. Okay? Now, we can take that and we can use it to solve for this one up here. So we know for this top one that our force of gravity on it is going to be the 7 kilograms we're told that it weighs times negative 9.8 meters per second squared. To get that, it's overall going to have a magnitude of 68.6 newtons. And since it's pointing down, that's negative 68.6 newtons. All right? So what we're going to do here is we're going to want to sum all of our forces in the y direction, which means we're going to want to add T1 plus T2 plus F sub g of 1, and we know that they all are going to equal to 0 newtons. Now, we're trying to get T1 alone, which means we need to move T2 and Fg of 1 over. So we're going to say T1 is equal to negative T2 minus Fg1. Okay, now T2 was already negative since it's pointing down, so it's going to now become positive 39.2. And then our f of g was already negative, so it'll become plus 68.6. So we're going to have 39.2 plus 68.6. And that's going to give us an overall tension of 107.8 newtons. All right, so there are cases 1, 2, and 3 for number 2. So let's move on to number 3. All right, so in number 3, we have our object, which it says is 25 newtons, which means the force of gravity is negative 25 newtons. And it's attached to a wall by 2 cables, and we're trying to solve for those tensions. Now, what we're going to want to do here is the first thing is going to be, do we want to sum our forces in the x or in the y? The answer is going to be that we want to sum them in the y. And why we want to sum them in the y is because we know a value in the y plane to help us find those other ones. If we tried the x's, we'd sort of get extremely stuck. So let's talk about summing our forces in the y direction here. What we're going to have is, of course, the force of gravity, and then we're going to want to add the tension of y. Okay, so the y components of tension, and they're all going to equal to 0 newtons because this is equilibrium. Now, like previously, we're going to want to sort of combine like terms. So we're going to have the force of gravity plus 2 Ty equals 0 newtons. Then we want to get the T alone, so we're going to subtract the force of gravity from each side. And what we're going to want to do here is we're asked to find tension, not just the y component of tension. So we know that we can represent this y component of tension by saying T sine of 30. So that's what we're going to sub in here. We're going to have 2t sine of 30 equals negative force of gravity. And how we get this t completely alone is we're going to want to divide both sides by 2 sine of 30, which means that we're going to end up with 25 newtons divided by 2 sine of 30, which when we type that into our calculator is going to give us an answer of 25 newtons. All right, and that's going to be our answer to number 3, 25 newtons. Okay? After we find that, it wants us to act like this was a 5-degree angle. All we would have to do is get rid of this 30 and sub it in with a 5. So now we would have 25 divided by 2 sine of 5, which is going to give us an answer of 143.42 newtons. Okay, so that's how it would change if it were 5 degrees instead of 30. All right, you guys, this was our image for number 4. We have some mass. It has a tension 1 of 30 newtons, well, magnitude 30 newtons. This would be represented as negative 30 newtons since it was pointing to the left. It has a tension 2 that makes a 60-degree angle with the horizontal and some force of gravity. We are asked to find tension 2 and the weight of this object. So let's start by solving for tension 2. Now, what we're going to want to do is this time we'll want to sum the forces in the x direction, because we don't know what this force is in the y direction, but we have an x to go off of. So that means we're going to have tension 1 plus the x component of tension 2 are equal to 0 newtons. So if we want tension 2 alone, that means we need to subtract tension 1 from both sides. Now, what we want to find is tension 2 overall. We don't just want this x component. So we know that the x component would be T sub 2 of tension 2 cosine of 60. So that's what we're going to plug in here. We're going to put T2 cosine of 60 equals negative T1. So when we do that and we just want T2 alone, we're going to need to divide both sides by cosine of 60. So we'll end up with that T2 is equal to negative T1 divided by cosine of 60. And when we plug that in, it'll be 30 newtons divided by cosine of 60, which is going to end up telling us that T2 is equal to 60 newtons. Okay, so the magnitude of T2 is 60 newtons. Now that we have that, we need to solve for the weight of this, or its force of gravity, okay? How we're going to do that is we're going to want to sum the forces in the y direction now, because this is on the y. So we would have the force of gravity and the y component of tension 2 all equal to 0 newtons. So in order to solve for the force of gravity, we're going to want to subtract that T2y from both sides. And to get this, we're going to need to use sub in. So we know that T sine of 60 is that y component. So we'll say that the force of gravity is equal to negative T2 sine of 60. And when we plug it in, that's going to be negative 60 sine of 60, which is going to tell us that our force of gravity is negative 51.96 newtons. All right, so that was number 4. All right, for number 5, we're given this image described to us. Okay, we've got a box. Someone's pulling on it with some applied force that they're pulling of 200 newtons at a 30-degree angle to the horizontal. And it says that the box is about 50 kilograms, which means the force of gravity on this is going to be negative 490 newtons. Now, it says the box doesn't budge at all, so the first thing we're asked to find is the friction force against it, okay? So, if we want to know the force of friction and it's on the x, what we're going to want to do is we're going to want to sum the forces in the x direction. So we're going to have friction plus the x component of that applied force. And since it doesn't budge, they're going to equal out to 0. So in order to find the friction, it's going to be the negative of that applied force in the x direction. And once again, we're going to want to sub in here that it is the negative of force, of this force, cosine of 30 degrees, which means 200 cosine 30. Remember, it's going to be negative 200 cosine 30. And what we end up getting is negative 173.21 newtons for our force of friction on this box. And the second thing we're asked to find is the normal force. Now, for the normal force, we're going to want to sum together everything in the y direction. So, when we sum together everything in the y direction, all those forces, we're going to have the normal force plus the force of gravity plus the y component of this applied force. And it's all going to equal out to 0 newtons. Because this box isn't flying up into the air or falling down into the ground. Remember, what we're looking for is normal. So we're going to want to subtract both of those over. So we're going to say normal is equal to the negative force of gravity minus that y component of the applied force. So here we're going to end up with 490 newtons minus, what this would be, minus 200 sine of 30. So when we do 490 minus 200 sine of 30, we end up with a normal force of 390 newtons. And the reason we did this is because the y component of this force is 200 sine of 30. Okay? So that's number 5. Let's move on to number 6 now. Okay, this time we have the same box, but now we're pushing down on it at an angle of 30 degrees with 600, okay, so now for this one, we've got the same box, but instead of pulling it at 30 degrees, we are pushing it at 30 degrees and are asked to find the friction again and the normal force again. So just so we're all on the same page, we'll go ahead and say that the y component of this, remember, is still going to be 200 sine of theta, and this x component will be 200 cosine of theta. And theta is 30, just for when we need to use those, okay? So this is the y component, and this is the x component, okay? So we're asked to find the friction first, so let's once again sum all of the forces in the x direction, which will be the force of friction plus the x component of this. We'll call this push, okay? And it's all going to equal to 0 because it's saying it's not budging again, which means that friction is equal to the negative force of the push, okay? Which means here the x and the y are both negative because it's in this third quadrant. So that will make this positive. So it'll be 200 cosine of 30. And 200 cosine of 30 is once again equal to 173.21 newtons. But this time it's in the positive direction, okay? Then it wants us to find this normal force, so we're going to want to sum the forces in the y direction again. So the force of gravity plus the normal force plus the the y component of this pushing force, which will all equal up to 0 newtons. So if we're looking for the normal force, we'll want to subtract these other two forces over. So normal is equal to the negative force of gravity minus that y component of the push, okay? So we're going to have 490 plus 200 sine of 30, which is 100, which means that this normal force is going to be 590 newtons. So here we have the answers to number 6. All right, with this, let's move on to number 7. Now, we have a man pulling a 50-kilogram crate across the floor at a constant speed, which means no acceleration. And what we want to find is the frictional force. So we're going to want to sum all of the forces in the x direction, which will be friction plus 200 cosine of 30, okay? Which means that friction is equal to the negative All right, guys, so in number 7, it says that we have a man pulling a crate that is 50 kilograms, meaning its force of gravity will be negative 490. He's pulling it at a 30-degree angle with 200 newtons of force, okay? So let's go ahead and break this one up into its two components. This one will be negative 200 cosine 30, and the y component will be 200 sine of 30, okay? Now what they're asking for us to find is this force of friction, which you'll notice is in the x direction. So we're going to want to sum our forces in the x direction, which means friction plus this X component of this pulling force, which will all equal up to 0 newtons since there's no acceleration going on, okay? Which means our friction will be equal to the negative pull of the X. So friction is equal to negative 200 cosine of 30, which is equal to 173.21 newtons. All right? Then it wants us to find his normal, which means that we need to sum all the forces in the y direction now since normal is in the y. So we'll have the normal plus the force of gravity plus this pulling force in the y direction, which will all equal 0 newtons. In order to get the normal alone, we need to subtract these other two. So we'll get that the normal is equal to the negative force of gravity minus the force of the pull in the y direction. So when we plug that in, we'll get 490 minus 200 sine of 30, which is going to give us 390 newtons of normal force on this man pulling the crate. Okay, so let's move on to number 8. Okay, number 8 says that a man pushes a 2-kilogram broom at constant speed across the floor. The broom handle makes a 50-degree angle with the floor, and he pushes with 5 newtons of force. So here is the broom that's 2 kilograms, and it says he's pushing on it at 50 degrees from the floor. So it makes an angle of 50 degrees with the floor, which means it's 50 degrees from the horizontal. Okay? And it says he's pushing with a 5 Newton force. And don't forget, since the broom's on the ground, we're also going to have a normal. Now, what we're asked to find is the normal force. So to start with, let's find what our force of gravity is. We know that the broom is 2 kilograms, so we're going to want to multiply that by negative 9.8 meters per second squared, which means that our force of gravity is negative 19.6 newtons. So in order to find our normal force, we're going to want to sum all of those forces in the y direction. So the normal plus the force of gravity plus the force of that push in the y direction, which will all equal our favorite number of 0. So to get the normal alone, once again, we're going to subtract the force of gravity and the force of that push in the y direction from both sides, which means we'll end up with 19.6 plus our force of the push in the y, which would be 5 sine of 50. And when we do 5 sine of 50, we get 3.83. So we would have 19.6 plus 3.83, which is going to give us 23.43 newtons of normal force for number 7. Now, we're not done. We also want to know the frictional force that is opposing this motion, which means once again, we're going to sum our forces in the x direction. So we'll have the friction plus the push in the x, which will equal out to 0. And to get the friction alone, it'll just be the negative force of the push in the x direction, which is going to be equal to 5 cosine, negative 5 cosine of 50. And negative 5 cosine of 50 gives us negative 3.21 newtons of force, or a frictional force, okay? That's a wrap on number 8. So let's move on. Oh, wait. No, it's not. We have a part C. If the frictional force were suddenly reduced to 0, what would happen to the broom? What do you guys think would happen to the broom? It would then whoosh, slide, right? All right, it wouldn't be going at a constant speed or anything. It would now be accelerating. Okay, now that we discussed that, let's go on to number 9. Guys, so in number 9, we're told that we have a 20 kilogram box laying on a ramp that is inclined at 30 degrees. We're asked to find the tension and the normal force acting on this box. So here I have my free body diagram. We have the force of gravity acting on it, which we know is negative 196 from doing 20 times negative 9.8. We don't have a value for the tension, we don't have a value for the normal, but we know that this angle right here to the horizontal compared to F sub G is going to be 60 degrees. So the first thing it wants us to find is tension, which means we're going to want to sum all these forces in the x direction. So we're going to have our tension plus our force of gravity in the x direction is equal to 0 since it's in equilibrium, which means that our tension is equal to the negative force of gravity in the x direction, which means it's equal to 196 cosine of 60. And when we do 196 cosine of 60, we get 98 newtons, okay? Then it wants the normal force, which means we have to sum our forces, and you guessed right, the y direction. So we'll have the normal plus the force of gravity in the y direction is equal to 0 newtons, which means we need to subtract over the force of gravity in the y direction. To get that, the normal force is equal to the negative force of gravity in the y direction, which means that it's equal to 196 sine of 60. And what 196 sine of 60 gives us is 169.74 newtons. Okay, so those are the answers to part A and B of number 9. And now we're on to the final event of number 10. Okay, so in number 10, we have a block on a ramp. And remember, we had 2 free body diagrams for this one. We had one that had a tension going up, right? It had its force of gravity pulling down, and it had the normal force acting on it. And we had tilted its axis. And then we had another one that had tension and the force of gravity acting on it, okay? And we just kept this one on its regular old axis of x and y. Nothing got tilted, okay? Now, it says that it's in static equilibrium, meaning that it's not moving, and we want to know what the mass of this block on the ramp is. And we're only given the mass of the block down below as 20 kilograms. And we know that this is inclined at a 35-degree angle, okay? So if this is 20 kilograms, that means 20 times negative 9.8. The force of gravity on this hanging block is going to be negative 196 newtons, okay? Now, if this is negative 196 newtons, and we want to solve for the tension here, we're going to add together the tension and the force of gravity, which are equal to 0 since it's an equilibrium, which means that the tension is equal to the negative force of gravity, so it's 196 newtons, okay? That tension is the same as this tension, so we know that this tension is equal to 196 newtons, okay? And we know that this angle right here with the force of gravity is going to be 90 minus 35, which means that the theta we're going to want to use for this force of gravity is 55 degrees. Okay? Now, in order to find this force of gravity, we know something in the x direction, so how about we sum the forces in the x direction, which means our tension plus the x component of the force of gravity, which will equal to 0. So we'll say that the force of the gravity in the x is equal to the negative tension, but we want this overall force of gravity, which means we need to say Fg cosine 55 is equal to the negative tension, which means Fg is equal to negative 196 divided by the cosine of 55, which is equal to 196 divided by cosine of 55, negative 341.72 newtons. And if we wanted this in kilograms, we would just divide it by negative 9.8. And when you would divide that by negative 9.8, you get that it would be 34.87 kilograms. 34.87 kilograms. All right, you guys, just want to make sure that was it. Those are all 10 of the problems. I hope this helped. If it didn't, I'm sorry. If it seemed like I was going too fast, well, I was trying to get this filmed during my Learn from Home class period. So my alarm just went off that I'm going to have some 7th period students coming in really soon. Good luck on your quiz that's coming up. I'm sure you're all going to do great, and I hope you're having a good day. Bye.